Hello everyone, welcome to 1000 Math 7. This is the video for exercise 1.2 of the chapter sets. Okay, so the first question is, which of the following are examples of null set? Now what is a null set? Null set means a set which is empty or empty set, and there are three ways to represent the empty set, right? The first is to put two curly brackets and no elements inside it, or to write a phi, or to just simply write as null set. So these are the three ways that we represent a empty set. An empty set means a set which is no elements inside it. Okay, that's why, see, this is a blank space that we have kept in between two curly brackets. Otherwise, if there would have been some elements, then we would have written some elements inside it. Like if there are some elements like 1, 2, 3 like that, then we would have written down the elements. But since empty set means empty, okay, so no elements. Now let's see the first one. Set of odd natural numbers divisible by 2. It talks about a set of what? Odd natural numbers. So natural numbers are what? 1, 2, 3, 4, 5, 6 and so on. And out of this, the odd numbers are what? 1, 3, 5, 7 like that. Right? Now, a set of odd natural numbers. Okay, this is a set of odd natural numbers, let's say. Okay, this is a set of odd as well as natural numbers divisible by 2. Now tell me, is any odd number divisible by 2? No, right? Because even numbers are the numbers that gets divided by 2. Odd numbers are not possible to divide by 2. So this set is a empty set, because when we try to write this set, let's say the name of the set is A, of this set is B, C and D, then set A is equal to, there will be no element inside it, right? Because there is no such number which is odd and a natural number and gets divided by 2. There is no such element. Okay, so this set is an empty set or a null set. I'll write E. Okay, now set of even prime numbers. Okay, it says a collection, okay, a set of even as well as prime numbers. So what are the prime numbers? Let's try to list out the prime numbers. The first prime number is 2, then it's 3, then 5, then 7, then 11 and so on, right? This is a collection of all the prime numbers. It goes on. Now you must know that all the prime numbers except for 2 is what? Odd numbers. 2 is the only even prime number. So here it says set of even prime numbers. So if this set is B, then B I can write what? If to write it in the roster form, I will just have one element, that is 2. So this is not an empty set. I have written NE. Okay. Now the next question is x such that x is a natural number. Okay, we know the natural numbers are this, comma, x less than 5 and x greater than 7. Okay, let's write down the natural numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. So it says that x is a natural number. Okay, so the set C, okay, I've just named it C. So the set C will have some elements which is less than 5 and also greater than 7. Tell me, is there any number which is less than 5 and which is also greater than 7? No, right? At the same time means both the conditions are true at the same time. Do not think it in this way, okay? That x is less than 5, so I can include the numbers 1, 2, 3 and 4. And x is greater than 7, so I can include the numbers after 7, that is 8, 9, 10 and so on. So I'll write the set as 1, 2, 3, 4, then 8, 9, 10. This will be a wrong answer. Why? Because both the conditions are supposed to be true at the same time. A number, a value of x that is less than 5 and that is also greater than 7, but there is no such number, right, that fulfills a condition like this. So this is also an empty set. There will be no element in this set when we try to write it in the roster form. Okay, now the next question is y such that y is a common point to any two parallel lines. Now what is a parallel line? Like this. If there are two lines in this way that do not intersect, then these two lines are called as parallel line. Now tell me, it says y such that instead of x they have just used y. Okay, so y, this set D will have some points, name of some points. Okay, so what is the nature of each point? Y is a common point to any two parallel lines. Tell me, two parallel lines, okay, they are parallel, so they will never intersect, so they will never have a common point. So is it possible to have a common point for two parallel lines? No. there will be no common point, because if two lines intersect, then only they will have a common point. This is a common point for both the lines, right? But if they intersect, then these are not parallel, okay? And if they are parallel, they will never intersect, and if they never intersect, they will not have a common point. So there is no such point that I can include in this set or in this collection, okay, that satisfies both the conditions. So this is also a empty set. This is an empty set, and this is also an empty set. Alright, now let's move on to the question number 2 here. Which of the following are finite or infinite? I have explained you in the lecture video. The finite set is a set in which whatever elements it has, we can count it. It's countable. And an infinite set, such a set in which the elements are uncountable. Okay. So let's see the set of months in a year. All of you know that there are 12 months in a year, right? In 1 year, we have what? 12 months, like January, February, March, April, May. So if I try to form a set, let's say this set is once again A, this is B, this is C, and this is D. They have not named the set, so I've just named it for your convenience. A is equal to the set of months. So I'll write for January, then February, then March, then April, then May, then June, then July, then August, September, October, November, and December. That's it. This is the set of month of a year. Now you can count them, right? There are 12 months. So this is countable. So this set is a finite set. This is finite set. Okay, we can count the number of elements. The next one, 1, 2, 3, comma dot dot. It means this is what? This set is the set of natural numbers, right? Starts from 1, then 2, then 3, and so on. We can go on writing as long as we want. We can write it for 1000 days in a go, or we can write it for 1 day in a go and write all the numbers that we want. But we will know we will have no point to stop. It will go on. So this collection will be infinite. So the set is what? Infinite set. Okay, infinite set this is. Now this one, it starts from 1, then 2, then 3, and goes on 5, 6, 7, 8, 9, 10 like this up till 100. So it's clear that there are just 100 numbers in this set. Okay, this is a set of natural numbers up till 100. So it starts from 1 till 100. So this is what? Finite. I can count how many elements are there. There are 100 elements. And then the set of positive integers greater than 100. So positive integer. So what's the number next to 100? It's 101, then it's 102, then it's 103, and I can go on writing in this way, right? So this is a collection that will have infinite number of elements, because it just has one condition, that it should be positive and greater than 100. Okay, fine. After 100 I get 101, I get 102, 103, I can go on writing, right? So this will have infinite number of elements. Okay, so this is a infinite set. Now the last one, the set of prime numbers less than 99. Okay, there is a limit. See, prime numbers, they start from 2, then I have 3, then I have 5, then I have 7, and so on. And there is an upper limit, 99. We need to check whatever the prime numbers are there before 99. So there will be a fixed number of prime numbers. Like I'll have some prime numbers here which can be counted. So this is also a finite set. Okay. Now the next question, state whether each of the following sets are finite or infinite. The same type of question we need to decide. The set of lines which are parallel to x-axis. Now all of you know about x-axis and y-axis, right? When we draw two lines in this way, this is the x dash, means the x-axis where xo part is positive and ox dash part is negative, and this is y dash. This part yo is positive and oy dash is the negative part of the y-axis. So this is x-axis and y-axis, and both of them intersect at the origin. This is origin or 0, 0. Okay, O, origin. Now the set of lines which are parallel to x-axis. Focus on this line, x-axis. We can draw many parallel lines. This is a parallel line, this is a parallel line to x-axis. The basic condition is that two lines are parallel only when they do not intersect at any point. They just go in this way. They will never intersect at any point. If you proceed on the line backwards or forward, it will never intersect. That or such a line is called as parallel. So I can draw many parallel lines, right? let's say this is line 1, this is line 2, line 3. I can go on drawing many lines. So the set of lines which are parallel to x-axis, there will be numerous lines, right? I can draw here also, here also, here also. So this set will have a lot of lines, like line 1, then line 2, then line 3, and so on. So it will have numerous elements. So this is infinite set. I cannot count how many lines, because I can draw as many lines as I want to draw, which is parallel to x-axis. The set of letters in English alphabet. English, all of you have learned from your childhood days, right? 26 letters, which can be counted. Yes, 26. So this is what? Finite. I know the English alphabet starts from A and it ends in Z, and there are 26 letters. It's countable, so it's finite. The set of numbers which are multiple of 5. Now what do you mean by multiple of 5? 5. Then 10. 5, this is 1 time, this is 2 time, then you get 15, then you get 20. Each of this is a multiple of 5. This is 1. This is what? 2 times 5. This is 3 times 5, 4 times 5, then 5 times 5. You'll get 25 and so on. So the set of numbers, if I form a set, the first multiple of 5 is 5 itself. Then I will get 10, then I'll get 15, then I'll get 20, then I'll get 25. And I can go on writing as long as I want to write. This is what? The set of the multiples of 5. Now it goes as long as you want to write. So there will be infinite number of elements, right? So this is an infinite set. Let's move on to the next question here. The set of animals living on the earth. Now this is a bit confusing, sort of, okay, like this was a bit confusing. X is less than 5 and x is greater than 7, but this is what? An empty set. Why? Because we need to consider both these conditions at the same time, okay? Otherwise you will get a wrong answer like this, okay? This is a wrong answer. Here also you may say that the set of animals living on the earth, there will be many animals, you can say, right? Like a lot of animals live on this earth's surface. If this is the earth, then there are numerous elements that lives here. Even some lives under the ground, okay? So you may say that this is a set, or this is a collection. If I try to form a set, I write the names of all the animals, then it will be a lot of animals. But it can be counted, right? Because animals are the living organism, so we can count it. If we deploy a set of people, go count and come back all the animals that are present in this earth, they can count. It will take some time, it will be a very huge number, but yes, it's countable. So this is finite, okay? Now the set of circles passing through the origin, 0 0. So set of circles passing through what? Origin. A circle that goes through the origin. So I've drawn the, okay, let me draw it once again here. Let's say this is the x-axis and this is the y-axis. So this is the origin. I can draw one circle that passes through the origin. I can draw another circle. I can draw another circle here. I can draw another circle here that passes through the origin. I can draw in this way also, that passes through the origin. I can draw in this way also. I can draw many circles that just touches the origin or just passes through the origin, right? Origin is a point which is 0 0, means in the x-axis it's the value of x is 0, in the y-axis also the value of y is 0. So the point is denoted as 0 comma 0, means first is x then y. We generally write a point as what? X comma y, right? So x is 0 and y is also 0. So this is origin. So there can be numerous circles. So this is infinite. This is infinite set. Now in the following state whether A is equal to B. So we need to decide if the set A is equal to set B or not. Now let me remind all of you, two sets, okay, let's say A and B are two sets. They will be equal only when elements, okay, or I can say number of elements in A is equal to number of elements in B. And the second condition is that elements of A is same as elements of B. Okay, if these two conditions that I have taught you in the theory lecture, if these two conditions are fulfilled, we'll say set A is equal to set B. And if any one of this condition is not fulfilled, then set A is not equal to set B. So let's check it here. The set A given as A, B, C, D. There are 4 elements and the elements are A, B, C and D. Set B has D, C, B, A. There are 4 elements. Now first, let's check the first condition here. Number of elements, 4. Number of elements, 4. Elements are A. Here also I have a A. Element B, there is a B. Element C, there is a C. Element D, there is a D. Okay. Same to same. The second condition is correct. So set A is equal to set B. Second one, the elements are 4, 8, 12 and 16. Then here you have 8, 4, 16 and 18. Let's check. The number of elements is 4. The number of elements is 1, 2, 3, 4. Right? Now check each of the element. Here I have a 4, here also I have a 4. Okay. Here I have a 8, here also I have a 8. Here I have a 12, but here I does not have a 12. So elements, even one element can affect the whole thing. Okay, so it should be exactly same like this, same to same. It can be jumbled up, but elements, each of the element should, that A has, B also should have that same element. Okay, here 12 is present in the set A but not in the set B. Similarly 18 is present in the set B but not in the set A. So second condition is not fulfilled, so set A is not equal to set B. Now let's look at the next one, this one. Set A is 2, 4, 6, 8, 10. Okay, this is the even numbers, right? 2 I get, then 4, then 6, then 8, then 10. And here the set B is in the set builder form, so let's try to get it in the roster form so that we can check what are the elements. Let's see here. Let's try to write it in the in the roster form. So X, okay, each of the element has been assumed to be X. And what is the nature of each element? Each element, or X, is a positive integer, okay, and X is less than or equal to 10. So tell me now, is a positive integer which is less than or equal to 10? You know integers, right? 0. On the right hand side of 0 you have all the positive numbers like this, and on the left hand side of 0 you have all the negative numbers like -1, -2 and so on, right? I think, let me check the question in the PDF of the new book. Okay, I think this should be even. Yes, it's a positive even integer. Okay, so the positive integers, they start from this place, from 1, right? And it says even also. So the first positive as well as even is what? 2. Then I'll get 4. Then I'll get 1, 6. Then I'll get 8, and then I'll get 10. I'll include 10 because it says less than or equal to 10. So 10 is the last element. So if you check here, 2, 4, 6, 8, 10, there are 5 elements. Here also there are, in the set A, there are 5 elements, and here also 2, 4, 6, 8, 10. So I can simply say set A is equal to set B. Please check this in your book. I may have written the question incorrectly, but since I have prepared this note, so I remember this should be even. Okay, even if it's not even, then this set will not be equal to set B. If, let's say, even is not there, it just says X is a positive integer, then positive integers will be what? Set B will look like, positive integers start from 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I'll write 10 because it is X is less than equal to 10. If this even is not there, then set B will look like this, which is not same as set A. In that case, set A is not equal to set B, but there is an even, as far as I can recall. There is an even that I have missed. So set A is equal to set B. This is the correct answer according to your book. Now the next question is, A, is X such that X is a multiple of 10? Once again, multiple of 10 means, let's try to write this set which is in set builder form, in the roster form. The first multiple of 10, 10 one time is 10. 10 two times will become 20. Multiple, right? Then 3 times will become 30. Then 40 and so on. Now this is the set A and this is the set B. I have B here, 10, 15, 20, 25. So you can clearly see that the elements are infinite, right? Dot, dot, dot is there, dot, dot, dot is there. We can write as many elements as we want to write. But if you check each of the element, there is a 10, okay, there is a 10. There is a 20, there is a 20. But here there is a 15, but on the set A, there is no 15. So set A is clearly not equal to set B. Okay. Now the next question is, are the following pair of sets equal? Give reasons. Okay, so let's try to solve this. Set A is 2 and 3. Okay, the set A has 2 elements, 2 and 3. And the set B, X such that, okay, this is in set builder form, X such that X is a solution of this equation. So let's try to solve this equation. This is a quadratic equation, x square plus 5x plus 6. So when we solve this equation, we'll get two values of x, because this is a quadratic equation, and that will be the set B. Okay, so let's try to solve this. X square plus, break the middle term, it's 2x plus 3x. Okay, together this will give you 5x. 6 is equal to 0. Then x, I'll take common from this 2, so x will remain here, and here 2 will remain. And 3, if I take common from these two terms, then x will remain here and 2 will come here. So this will be 1. Now take x plus 2 common from both of them, x plus 2. Then here remains x, and here remains plus 3 is equal to 0. So x is equal to what? Either this is 0 or this is 0, because the multiplication of these two terms is what? 0. So x plus 2, if this is 0, then x is equal to minus 2. Take the, in this way, x plus 2 is equal to 0, then x is minus 2. Take the plus 2 on the other side, it becomes minus. And if this is 0, then x is equal to minus 3. So I got two values of x. So the set B is what? Set B is what? Minus 2 and minus 3. Now compare. There are two elements in this set A, and there are two elements in this set B. So the first condition is good. Okay, the first condition that I have written down, I think. Yeah, the first condition is good. But the second condition, see, here I have a 2 or plus 2 or a 3 or a plus 3, but here both the numbers are negative. They are not same. Plus 2 and minus 2 are not same. Okay, so I'll say set A is not equal to set B. Now next one, A is what? X such that X is a letter in the word follow. Okay, the set A, it's given in the set builder form, and if we try to write it in the roster form, then A is equal to what? Here I'll write down the elements of this set, and what are the elements, or what is the nature of each element? Each element has been assumed to be X, right? So what is the nature of each X? That it is a letter in the word follow. So let's try to write. The first letter is F. Is there any repetition of F? No. So F. Then I have O. O has been repeated twice. See, so I'll just include one O. Then L has been repeated twice, so I'll just include one L. And finally W. So this is a set of what? Letters. Different letters that I can see in the word follow. Now let's try to form the set B, because it is also in the set builder form. So B says Y. So each of the element that will come here has been assumed to be Y. And what is the nature of each Y? Y is a letter in the word wolf. Wolf is an animal. So let's try to write the letters in this word. W. I have a W. There is no repetition. O. I have a O. I have a L. And I have a F. Right? Now compare. There are 4 elements here. There are 4 elements here. Okay. The first condition is good. Check the second condition. Each of the elements are same or not. Here the first element is F. Here also I have a F. Okay. I have a O. I have a O. L. L. W. W. So same to same. So I'll say set A. I'll write it here. Okay. Set A is equal to set B for this. And for this, set A is not equal to set B. Okay. Now, from the sets given below, select equal sets. So we need to decide. There are 8 sets, A, B, C, D, E, F, G, H, and we need to decide which of them are equal. Like if A is equal to B, or B is equal to D, or E is equal to F, like that. We need to compare each of them and check. Now see here, the set A has 1, 2, 3, 4 elements. This set B also has 4 elements, but if you see, set B has 1, 2, 3, 4, and this is what? 2, 4, 8, and 12. These are all even. I have odd numbers also, so no point comparing set A and set B, although the number of elements are same, but each of the element is not same. Now let's check A with C. 2, 4, 8, and 12. Here I have 12, I have 8, I have 8, I have 4, but I don't have a 2, so no point comparing A and C. No point comparing A and D, because it's 2, 4, 8, and 12. I have what? 1, 2, 3, and 4. And rest here, there are just 2 elements in all of them. So A is not equal to any one of them. Let's take B here. B, no point comparing to A, because we have already compared A with B. That's the same thing. So let's compare B with C. 1, 2, 3, 4. 4 elements, 4 elements. Okay. Here they have 1, 2, 3, and 4 as the elements. Here they have 4, 8, 12. Completely different. Okay. No point comparing B and C. Let's say D, B and D. Okay. So B has 1, 2, 3, 4. D also has 1, 2, 3, 4. See, 4 elements, 4 elements. Each of the elements are same. So B is equal to D. This is the first 2 sets that are equal. Now let's try to compare B with E. No point, because 2 elements, there are 4 elements. 2 elements, 2 elements, 2 elements. Okay, leave it. Now let's take C. 4, 8, 12, and 14. C, if you compare to A, no point. B, no point. If you compare to D also, no point, because although the number of elements are same, 4, 4, 4, 4, but each of the elements are different. Okay, so if you take D also, then D is only equal to B, which we have already done here. Okay, now the next part here, E, F, G and H, all of this has two elements, so we will not look on this side now. Okay, let's just compare in between this two, because if we look on this side, here there are just two elements, here there are just four elements, so it's not comparable at the first point itself. Okay, so E has -1 and 1. Check if there's any other set that has -1 and 1. Yeah, this one, see, E and G. E will be equal to G because both the elements are same, number of elements are also same, and rest nothing is same. Okay, if you try to compare. So these are the two sets that is equal. Alright, so thank you for watching this solution video of exercise 1.2, and we will meet in the next video. Thank you.